Good day, learners! Welcome to our Quarter 1 Week 2 video lesson on Mathematics 10 with competency determines the sum of the terms of a given arithmetic sequence. And I am your teacher, Ma'am Pearl Mizrak G. Barongan, and I will be discussing the presentation prepared by Ma'am Medea C. Catalan. Here are your points to remember. An arithmetic series is the sum of the terms of an arithmetic sequence. It is the result of adding the definite terms of an arithmetic sequence. When we say definite, it is defined to have the first and last term. We have your formula 1. If S sub n represents the sum of an arithmetic sequence with terms a sub 1, a sub 2, a sub 3, up to a sub n, then S sub n is equal to n over 2 multiplied by a sub 1 plus a sub n, where a sub 1 is the first term and a sub n is the last term, while n is the number of terms. This formula requires the values of the first and last terms and the number of terms. We have your formula 2. S sub n is equal to n over 2 multiplied by 2 times a sub 1 plus quantity n minus 1 times d. This formula for the sum of an arithmetic sequence requires the first term, the common difference, and the number of terms, where a sub 1 is also the first term, n is the number of terms, while d is the common difference. For you to better understand all about arithmetic series, let's have an example on your Activity 1 entitled Summing Up. The direction: what is the sum of the terms of each arithmetic sequence below? So your sequence is 1, 3, 5, 7, 9, 11. So for your solution, we have your A1 or the first term, which is equal to 1. And we have your D or the common difference, which is 2. We got 2 from 3 minus 1. 5 minus 3, 7 minus 5, so we have 2 as your common difference. And your n, the number of terms in the sequence, we have 6 because we have 6 terms. So we will use the second formula, wherein we have the first term and the common difference. So S sub n is equal to n over 2 multiplied by 2 times a1 plus quantity n minus 1 times d. So let's have the substitution. S of n, so n would be substituted by 6, and your a1 would be substituted by 1, and your d would be substituted by 2. So we have 6 divided by 2, we have 3, and 2 times 1, we have 2, and 6 minus 1, we have 5. So, continuing here, we have 3 multiplied by quantity, 2 plus 10. We got 10 from 5 times 2. So, 2 plus 10, we have 12, and 12 times 3, we have 36. So, the sum of the terms of the arithmetic sequence is equal to 36. So let's have an example on your Activity 2 entitled More Series. The direction: evaluate each arithmetic series described. So the given, we have a sub 1 equal to 2, a sub n equal to 20, and your n is equal to 6. So what you can say on the given? We don't know the common difference or the d. So in here, we would be using the first formula. So there you have it, the solution. Use formula 1. S sub n is equal to n over 2 multiplied by quantity a sub 1 plus a sub n. So we have, by substitution, we have all the values of n would be substituted by 6, and your a1 would be substituted by 2, and your an would be substituted by 20. So we have 6 divided by 2, 3, and your a1 is 2, your a sub n is equal to 20, so we have 22. 22 times 3 is equals to 66. We have another example on your activity 2. So we have the sum of the sequence 2n from first up to the 8th term. So the Greek letter sigma symbolizes that we are looking for the sum of the sequence 2n. So for your solution, we have your a1, or your first term, is equal to 2, and your n is equal to 8. So we would substitute n from numbers 1 to 8, then add the values. So in here, we have 2 times 1, we have 2. 2 times 2, we have 4. 2 times 3, we have 6. 2 times 4, we have 8. 2 times 5, we have 10. 2 times 6, we have 12. 2 times 7, we have 14. And lastly, 2 times 8, we have 16. So we add all the 8 terms, and we will be getting 72. So the answer for the sum of the sequence 2n is equal to 72. And lastly, for your activity 3, we have your example. So here is the direction. Solve for each of the following problems. So example number 1, find the sum of the first 100 positive multiples of 3. So for your solution, the sequence of positive multiples of 3 is an arithmetic sequence where a sub 1 is equal to 3 and the common difference is equal to 3. That is the sequence 3, 6, 9, 12, 15, and so forth. Of the first 100 terms, the last term is denoted as a sub 100. To find our a sub 100, we would use the formula a sub n is equal to a sub 1 plus quantity n minus 1 times d. So we are looking for a sub 100. So for your an, we have a sub 100 is equal to 3 plus quantity 100 minus 1 times 3. So we have 100 minus 1 equal to 99. And 99 times 3 is equal to 297 plus 3. Thus, your a sub 100 is equal to 300. Now that we have your a sub 100, we will use the formula a sub n is equal to n over 2 multiplied by the quantity a sub 1 plus a sub n to find the sum where n is equal to 100 and your a1 is equal to 3 and your a sub 100 is equal to 300. So your sum of 100 terms is equal to n over 2 multiplied by the quantity a sub 1 plus a sub n. So we would substitute your n is equal to 100, your a1 is equal to 3, and your a sub n or your a sub 100 is equal to 300. So 3 plus 300, we have 303 multiplied by 50, so we have 15,150. So we have another solution. We would use the second formula, wherein s sub n is equal to n over 2 multiplied by quantity 2 times a sub 1 plus quantity n minus 1 times d. in finding the sum. So your A1 is equal to 3 again. Your common difference is 3 and your N is 100. So we have, by substitution, 100 over 2 multiplied by quantity 6 plus 99 times 3. So we would still end up with the same answer, which is 15,150. Thus, the sum of the first positive multiples of 3, or the first 100 multiples of 3, is 15,150. So there you have it for your week 2 sum of an arithmetic sequence. Thank you so much for listening and stay tuned for the next virtual instruction. Have a nice day.